Hello, students. Hope you all are doing well. We will start the class with the new chapter, Chapter 4 Magnets and Electromagnets. You can refer this chapter in your science book too. Students, have you seen these types of magnets? The first one is a horseshoe magnet and the other is a bar magnet. You know that these magnets can attract or repel things. All the magnets or magnetic material have a basic property known as magnetism. When a magnet attracts or repels something, a force comes into act between the magnets or between magnets and materials such as iron and steel. This is known as magnetism. These magnetic forces act over only small distance, usually just a few centimeters between the magnets and objects. But we can use the magnetism to a great effect. You can see some pictures here. All these devices use magnets in one or other form. The door of the refrigerator contains magnet. Similarly, the headset also contains magnet inside it. An electric drill have a magnet inside its motor. But all they do have the same type of magnets? No. Based on magnetism, there are two types of magnets: permanent magnet and electromagnet. Electromagnet is also known as temporary magnet. For a permanent magnet, once it is magnetized, it can restore its property. A permanent magnet is a magnet made from a piece of iron or steel which has been magnetized so that it keeps its magnetic properties. Students, electric current also exerts a magnetic force. By using this fact, we can make another type of magnet which can be turned on and off. These are electromagnets. They are temporary magnets as they will lose their magnetism when the electricity is removed. The magnet in the door of the refrigerator is a permanent magnet, whereas the motor of the electric drill have electromagnet. In the case of a headphone, it uses both permanent magnet and electromagnet. If a bar magnet is dipped into iron filings, the filings stick to both the ends of the magnet. Isn't it? Have you ever noticed that when two bar magnets are both near, sometimes they will get attracted or sometimes they will repel? Let's see what makes the attraction and repulsion of magnets. Students, look here. There are two bar magnets. What do you notice about them? Look at the ends. Do you see the markings? One end is marked as N and the other end is marked as S. Now, let's bring the two ends of the magnets marked with letter N close to each other. You can see that both the ends tends to repel or move away from each other. Let's try the same with the other end marked with letter S. We can observe that the ends of the magnets marked with the same letters repel each other. Now, if you bring the opposite ends, that is, the end marked with N and the end marked with S, close to each other, we observe that opposite ends attract or move towards each other. The N and S marking on the magnet defines the north and south poles of a magnet. All the magnets have two poles. The earth affects magnets. You know that for the earth also there are north pole and south pole. If a bar magnet is hung from a thread as shown in the figure, it comes to rest facing north to south direction of the earth. The end of the magnet which points to the north of the earth is called as the north-seeking pole, and the other end is the south-seeking pole of the magnet respectively. For all types of magnets, they have a space around them where magnetic materials feel a force. This is known as the magnetic field. You can observe magnetic field around a magnet by a simple lab activity. For this, you need some iron filings, bar magnets and an A4 size paper. Place the bar magnet under the paper. Sprinkle the iron filings uniformly on the top of A4 sheet in the region above the magnets. You can observe a pattern formed around the magnets. This pattern describes the magnetic field of the magnet. Magnetic field can also be studied by using a plotting compass. This is a plotting compass. It has a needle which is a small magnet. The needle of the compass always comes to rest in line with the magnetic field of Earth. You can follow these steps to plot magnetic field by a compass. Step 1. Place the plotting compass near the magnet on a piece of paper. Try to keep it near any one of the poles. Step 2. Mark the direction of the compass needle using a pencil. Step 3. Move the plotting compass to many different positions around the magnet and mark the needle direction each time. Step 4. Once you complete, join all the points to get the field lines. The diagram shows the magnetic field pattern around a bar magnet plotted using a compass. You can see spacing between the field lines. The spacing shows the strength of the magnetic field. You can notice that the lines are closer near the poles. This shows that the strength of the magnetic field is greater near the poles. The arrows on the magnetic field shows the direction of the force acting. They always run from the north pole to the south pole of the magnet. This is the diagram of magnetic field pattern produced when unlike poles of two magnets are brought close together. You know that unlike poles of two magnets will get attracted, so their magnetic field lines are intersected. Similarly, this is the magnetic field patterns produced when like poles of two magnets are brought close together. Since like poles repel, the field lines of these two magnets will not intersect and they will get diverged from each other. Hope you understood about magnets and magnetic field. We'll meet you in the next class with more interesting facts about magnets. Thank you.